Found at Moodle in the test 1 practice area. We're going to draw 2 chair conformations for each di-substituted cyclohexane below. 2 problems. On your test, because in these days of COVID, we do not have as much time for tests, you'll only do one like the second one, but the first one provides a better introduction. So after you've learned how to draw chairs based on lectures and on textbook first and then videos, you'll be coming in with this as a starting point, parallel lines from the inside one, parallel lines going more than halfway, and then finishing it off for our first chair. And that's a little rusty for me. Oh, I liked my first one. There we go. Everything should be parallel lines across from each other. Chair number 2, similar story. Inside more than halfway, inside more than halfway. Went a little too far on that one. And this should be connecting. There we go. And you decide where you want carbon 1. I'm going to tell you right now, I'm a happier teacher if everybody chooses the same carbon 1, like the top right carbon. You'll notice almost every answer key, I put carbon number 1 on the top right. Let's put them in. You don't need to number yours. I'm just putting numbers here. 1, 2. In this question, we care about carbons 1 and 4 in particular. Please don't choose top right carbon for carbon number 1 in chair number 2, because when you do a sigma rotation of all the bonds to get from one chair to the other, any carbon angle that was pointing upwards, like this angle here, this is a kind of an arrow pointing up. When you do the chair rotation, up things, when you sigma rotate, end up being down. So if you pick this to be carbon 1, you're in good shape. Make sure it's on an angle pointing down. On your first chair, you decide whether you want the hexyl group on 1 to be up or down. There's no right answer. If you choose up, then you've chosen the axial bond. Hexyl 1, 2, 3, 4, 5, 6. And that's the axial bond. You get a half point in part B for actually saying it's axial. And on carbons 1 and 4 in this question, carbons 1 and 4, please put on all of the bonds. If the axial is up, straight up on a carbon, then the equatorial is slightly down. And I want to remind you, it's parallel. This bond should be parallel to not this bond, but the next one. It should be parallel to not this bond, but the next one. Remember, they were parallel to each other. They should both be parallel to this. That's how chairs look. In class, when we've met in person back in the good old days, I would show the toys and walk around the room, and it was good fun, but not for us this semester. Now, your days of choices are over because the name says cis. And what's important about this group you drew is not the fact that it's axial, but the fact that it's up. Cis means either up for the 2 groups or down. If you wanted down, you shouldn't have put the hexyl where you did. You should have used the other bond. You chose up, which is fine. Your neopentyl on 4 has to be up. And which of these 2 bonds that I'm going to draw is the one that's up? And another question, why am I drawing that bond first? It's because that's the axial bond. and it follows the angle. If the angle of the carbons points down, which this does, the axial is straight down. If the angle of these bonds points up, the axial is straight up. And I drew the axial first because that's the way you should go. And equatorial should be parallel to this and this. And I used my eraser instead, and that's not wise. Move that a little if it lets me. I doubt it will. It did. There we go. And cis means up. This is up. Which of those two bonds is up? That one. Slightly up, equatorial. The important thing is it's up. Neopentyl goes there. Neopentyl, if you haven't reviewed that, is a 5-carbon group, as the name suggests. And it starts with a CH2 right there and ends with the old chicken foot. And we have an H down here. Please don't leave the end of a stick. That's going to be a methyl, and I'm going to say you got to lose a 1/4 point because you put a methyl in a molecule that shouldn't have methyls. All right. And that bond was what, axial or equatorial? Part B, label each R group. This is an R group. This is an R group. We labeled that one already. Well, we could have used the short form AX. I didn't notice that. There we go. Or EQ for equatorial. That's the one for the neopentyl. And in the other chair, you have to remember that when you do the sigma rotations of the bonds, going from one chair to the other, any group that was up in one chair will also be up in the next chair. But any axial bond becomes an equatorial bond, and any equatorial bond becomes an axial bond. So in the other chair, this group, this hexyl group, has to still be up, and it has to be equatorial. And that proves that we did a good choice on carbon 1 here. Axial first is straight down. Pen is off. And equatorial is slightly up. Parallel. I could have done a little better, huh? Yeah. Make it more parallel to that and that. Yeah, it is. There you go. And which of those has to have the hexyl? The one that used to be axial up has to be up still. That's the up. It's equatorial. Hexyl goes there. 1, 2. Yuck. 1, 2, 3, 4, 5, 6, and H. And you get a ½ point more for EQ. Go to carbon 4, put the axial on first. It goes straight up. Equatorial, slightly down. Parallel to 2, 3, and 5, 6. This used to be up. It better still be up. Neopentyl, as promised, is axial. And it's still up because in a chair, when it does sigma rotations of bonds, ups stay up and downs stay down. So up hexyl is still up hexyl. Down H is not still down H. Up neopentyl is still up neopentyl. Down H is still down H. Equatorial becomes axial. Axial becomes equatorial. Very good. And to answer the explain part, you get a point for circling that. And then you have to describe which group wants to avoid 1,3 diaxial repulsions. So if you're watching this video before you've even studied 1,3 diaxial repulsions, it's making no sense. But this group is a bulkier group. So when it's here, it's going to be real close to this H here, that's 2 carbons away, and this H that's axial here, also 2 carbons away. We call that a 1,3 diaxial repulsion, and bulky groups suffer from those worse than this linear group. There's no branching here. You can get this whole tail away from the ring, and there's no negative 1,3 diaxial repulsions. So in words, you just say in chair 1, in fact, you don't even have to say in chair 1, you circled it already. The bulkier, I need to see the word bulkier. Neopentyl avoids 1,3-diaxial repulsion, which is a form of steric hindrance discussed in both the textbook and in videos. And that ran us how